guys. Welcome to another edition of Patio Productions. So many fun things going on here. Oh, some cars going by. Some traffic out there on my street right when I started, of course. So here's the deal. Ladies and gentlemen, we are about to begin chapter 16. Chapter 16 is like some good stuff. Okay, so chapter 16 gets into what would be the beginnings of a calculus course. Okay, so we're actually doing some foundation laying for a course that you may be taking next year. We are covering 3 of the sections in chapter 16, so just 16, 1, 2, and 3, but we're going to spread this out like over a lot of days. Okay, so we're going to take it nice and slow. Your homework assignments are going to seem short. That's what I want to happen, right? I know you're very excited about that. Okay, so super short, nice homework assignments, and we're just gonna spread them out, and then we'll be taking our tests when we take our tests. So let's go ahead. This will be our last chapter test. Okay, let's get right into this. So here we go, ladies and gentlemen. Let me get the PowerPoint pulled up. Here we go. Here we go. Okay, so here is our PowerPoint lesson coming up right now. Okay, and so of course you're going to want to write down the title. So we're talking about this something called the limit of a function of a real variable, and you can see that this is again going to be our day 1 of this topic. Day 1. I am going to have to jump to Desmos a little bit. If we were in class, we would be all getting out our phones and sort of like doing it together. If you want to do it with me, be my guest, okay? And if not, you can just watch it. That's fine too, whatever you guys wish to do, okay? So during this first part, actually, we would have just been doing exploring on our phones, not taking notes. I'll tell you when you should start writing things down, okay? So we're going to be just exploring at this moment. And so what's going to happen is we're going to go and look at a graph, but we're also going to consult a table of values for that graph. And I want to look at a couple of things, okay? So I'm going to go to Desmos right now, and this is the function that we're going to be exploring. F of x equals 0.5x plus 3. Okay, so I'm going to jump myself to Desmos right now. Hopefully it's going to just jump there super quick. Oh, look at that. Okay, so I have preloaded it with this function already in here. As you can see, it says f of x equals 0.5x plus 3. Okay, I want us to make a table of values because I have this point I want to prove, okay? The way that you make a table of values is you use this plus sign up here, and then you go and you say, oh, I would like to make a table, okay? I don't need to say x sub 1, but I do want this to say f of x. So I'm going to just put in the y column f of x, and then it'll actually kind of make this super nice. So every time I put in an x value, it will just automatically put in the appropriate y value. I know, so fun. So I would like to put in a 1, and when I hit, I don't even have to hit enter, it just automatically says, oh, it's at 3.5. So 1 comma 3.5. Okay, if we go to the next one, what if I put in a 1.5? Oh, look at that. The next one I want to be a 1.75. Oh, that's entertaining. Okay, I'm going to do a 1.85 next. And then maybe a 1.95 next. And then, just to be super crazy, 1.99, okay? Now, I want you to just put your eyeballs right here on these y values, okay? The coordinate was 1, comma 3.5, 1.5, comma 3.75, and we just kept getting closer and closer and closer to an x value of 2. And then these y values are doing something. Now, I know this is crazy, but I am going to skip an x value of 2. I know. I wonder why Mrs. Fox is doing that. Well, let's skip it. What if I went for the next one, 2.001? What about if the next one I said 2.05? And then I went 2.15, and then maybe 2.25, etc. Okay? What I want us to look at on these y values is as the x values were getting closer to 2, either coming in right here, coming in, or maybe even coming the other way, coming from the other side, and the numbers were getting smaller and closer to 2, what were these y values doing over here, right? Well, doesn't it look like that these y values were getting closer and closer and closer to one particular y value? So let's think about that for just a moment. Just think. What y value is it getting closer and closer and closer to? If I were to zoom in on this graph, what y value am I getting closer and closer and closer to? Well, what number does it look like? I think it looks like the number 4. Isn't that the coolest? Ladies and gentlemen, this idea of trying to like target in on an X number and then having a resulting Y number be an answer has a special name. So I was going to put a movie clip. If we were in class, we would have a movie clip right here. Ooh, and it would be from Mean Girls, and it would be the math competition towards the end of the movie, and Katie's at the helm, and she's trying to guess, and she's thinking, and the other girl gets it wrong, and so she has to think. So she does this little montage about the so-and-so, the cute boy, having this great hair. Maybe he got a haircut, I can't remember anyway. And then she says something like, the limit does not exist. Okay. So this idea, this word of limit, okay. So this idea of a limit is what we're talking about. So I want to talk about something else. I want to change up the function here. Okay. So I want to change the function to not be this. And you know, what's nice is that all of this is already preloaded. So I'm not going to have to enter any of this table again. I can just go up here and change my function. So I'm actually going to do for this function, I'm going to do a fraction. So I'm going to do a parentheses 2x minus 5, and then oops, I did not say 2x. That was silly, Mrs. Fox. Okay, so 2x minus 5, and then I'm going to divide by an x minus 2, and I'm going to sort of reset my picture here. Okay, and if you can kind of look at this guy, let's look at the table of values. Okay, whoopsie daisies, there we go. So on the table of values, it looks like I put in 1, and all of these like automatically switched. So as I'm getting closer and closer and closer to 2, just like from 1, 1.5, 1.7, it looks like these numbers are getting larger. In fact, 1.99 turns out to be 102. Then I go over here to 2.001 and then 2.05. These numbers look like they were coming. And these numbers were getting super negative, right? Okay. So on this particular graph, it looks like as we're targeting in on the number 2, we are not going towards one particular value. In fact, it looks like that over here, it looks like these values are getting really large, and then these values are getting really small, okay? This is that idea that Katie was talking about in that movie, where we say that the limit does not exist, okay? So this is saying because there's not one particular Y value that it's going in towards, then that means that the limit does not exist. I know, that's super fun. Okay. Now I want us to just think about just this for just a minute, just a little bit different notation. Okay. What if we looked at this graph and I said, I want to know what happens to the Y value as the X values get super big. So if I'm looking at this graph right here and I just kind of like shift it a little bit. Okay, I'm just going to start making the X values really big. What do you guys notice about those the Y value as the X values are getting really big? Isn't this X value right here just kind of like hanging out? The X value keeps getting larger and the Y value is getting closer and closer to 2. Okay, so we're going to say something like the limit as X approaches infinity is going to be a 2. Now let's get this graph way back yonder to where the asymptote was. Here we go. And let's go ahead and go towards negative infinity. So I'm just going to keep on pulling my graph, pull the graph as I'm going to negative infinity. And look at these graphs. So as the X values are getting smaller, what are the Y values doing? Well, the Y values are also getting closer to 2. Ladies and gentlemen, the limit as X approaches negative infinity, the Y value happens to be 2. Okay, so that was a lot of words and not a lot of writing. All of this stuff that was on the PowerPoint was exactly what I did in the Desmos. So I'm just gonna kind of jam through this like whoo, crazy style. Look at this. Woo. Okay, and now I want you to start writing. Okay, so I want you to write this sentence right here. It says the ideas of the X values getting close to something like a target value and the resulting Y values getting close to something else is the idea behind a limit. Yeah, now there is a precise definition for limit, but we're just going to roll with this for right now, okay? So I want you to write that sentence down. These ideas of the X values getting close to something and the resulting Y values getting close to something is the idea behind a limit, okay? So the notation that I'm talking about, so I've been saying these like words and you're like, Mrs. Fox, I don't even know what you're saying, okay? And so what we're doing here I'm gonna see if I can get my pen to go here. Okay, this right here is our notation that we want to write down. So this is like what I was saying. The abbreviation for limit is the just abbreviation LIM, and then underneath it you write X, and then there's an arrow, and then this A value right here is a number. Okay, it may be like 5 or 2 or infinity or -6 or anything. Okay, so your number goes there, and then this right here is where your function goes. And then this is the answer. Okay, so I want you to know something to just, I'm going to harp on this today. The answer to a limit question is a Y value. Okay, ladies and gentlemen, I really want that to get stuck into your brain. Okay, the answer to a limit question is a Y value. There's going to be a target X value, and this is the target X value that we're going for, and this is our function that we're working with, and then the answer is going to be a Y value. Okay, so sometimes we get these by looking at a graph, okay, just like we did with our exploration. So I'm going to hop over to Desmos just real fast again. I want you to write all of these down first, though, before we jump to the Desmos graph. So can you guys write these down, please? Okay, it says using the graph on Desmos, and of course you can do it on your phone. Okay, I want you to find the limit. So part A, we're writing all of these down right now. Part A says the limit as x approaches infinity of x cubed. Part B says the limit as x approaches negative infinity of x cubed. Part C says the limit as x approaches infinity of tangent inverse of x. And then part D says the limit as x approaches negative infinity of tangent inverse of x. So I want you to write all of those down. And then I'm going to go and I'm going to click to the Desmos graph. And we are going to, where's my arrow? I need to get my arrow. Okay. We're going to my arrow back. We're going to go to the Desmos graph. So we're going to go to Desmos graph. Now I have pre-done these graphs in my Desmos. So all we have to do is look at them. So exciting. I'm going to just turn them on. Okay. So we don't have to do a, table this time. We're just going to literally look at the picture. So for part A and part B, okay, what is with the motorcycles going down my street today? Who knows? Who knows? But there they go. Okay, we're going to turn on y equals x cubed. And here is this beautiful graph. Ooh, that's a beautiful graph, okay? So for part A, it said as x approaches infinity. So we're going to say as the x values get larger, okay, what is happening to the y values? Well, guys, this is y equals x cubed. Wouldn't there be like an error? Look, doesn't this graph just keep going up and up and up and up and up and up? Folks, the y value that it's heading for, because it just keeps getting larger and larger and larger, is infinity. Okay, so we're going to say that this guy is infinity for that answer. So the answer to question A is infinity. What about part B? Well, part B says the limit as x approaches negative infinity. Okay, so if I'm getting larger and larger, well, I guess smaller and smaller on the x's, okay, what's happening to the y values? Well, the y values are also getting negative, 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 right? If I just kind of keep scrolling down here, as the x values go more negative, so do the y values. So we're going to say that this guy is going to negative infinity. Let's turn that graph off and answer part C for this tangent inverse graph. I mean, I love tangent inverse. He is such a cool looking guy. Okay, this is one of those ones that I'm really going to ask you to like harp on and try to really get in your brain going into calculus for next year. So I don't know if you remember this sort of like sideways swimmer stroke, but didn't this like have asymptotes? I think it did. Do you guys remember that the regular tangent graph has asymptotes that go because of like the whole bananas and rainbows thing that we like to do, that goes from a negative pi over 2 to a positive pi over 2? And then when you do the inverse graph and you do the Sharpie math, anything that was like vertical is now going to be horizontal. Okay. And so if I were to put in here the equation of y equals, and then I typed in pi over 2, which let me get my pi symbol really fast. Pi over 2, that is an asymptote line. Okay, let me also type in y equals negative pi over 2 and check this guy out. I think I'm going to make both of those graphs dotted super quick just so it's not as crowded. And let's do this. Okay, check this out. Ladies and gentlemen, as x approaches infinity, right? So as this x keeps getting larger and larger and larger and larger and larger, what is the y value that these guys are getting close to? The y value that it's getting close to, that asymptote, is pi over 2. So the answer to part C of our question would be at pi over 2. Similarly, as we go to negative infinity on the x's, if I just make this graph go more and more and more and more negative, what is this value going to? It's just going to keep on going more this way, and it's going to a negative pi over 2. So let me switch back to the PowerPoint so we can fill in those answers. So just as a review, the limit as x approaches infinity of the x cubed got way super big, so it went to infinity. As we approach negative infinity, it got way super small, so it goes to negative infinity. For part C, it went to a pi over 2, and part D went to a negative pi over 2. Okay, very nice. So here's the deal, guys. These beautiful graphs, lovely, lovely, all these things, you had to do these limit questions by looking at the graph. And that is like so acceptable and lovely and a way to do it. But is there other ways to do it? And the answer is yes, there is other ways to do it, especially if it's more like algebraic in nature, kind of like a polynomial. So let's do this example right here. This is example number 2. It says find the limit of this guy. Okay, now I could like plot this and graph this, but I don't need to. Okay, when you just have something simple right here that's an algebraic guy, okay, then what happens is that you can just take this negative 1/5. This just say negative 1/5. And all you have to do, it's actually super simple, is plug it in for the x value. Okay, so I'm going to take a negative 1/5 and I'm going to plug that value in. If I do that, it'll have a 5 times a negative 1/5, which is going to be a negative 5. Negative 5 plus 3 happens to be a 2. Is it supposed to be negative 2? Wait a minute. It's positive 2. Mrs. Fox can't multiply right now. Okay, we're going to have, she messed up. Okay, seriously. She forgot how to multiply. So if you were wondering 5 seconds ago, I did the wrong thing. Okay, so we're going to take 5 times negative 1/5, and we're going to get negative 1. Oh, that's better. And then we're going to add 3. And then what do we get? Yes, we do. We get an answer of 2. Nice. Okay, let's do another sort of algebraic one. This just says the limit as x approaches negative 2 of 6 minus x cubed. Again, that's how I'm saying it. The limit as x approaches negative 2 of 6 minus x cubed. So I'm going to write this down. I'm not going to mess up this time. We're going to go 6, and we're going to minus, and then in parentheses, I'm going to put negative 2, and I'm going to raise that baby to the 3rd power. Negative 2 to the 3rd power would be a negative 8, which means this is going to be 6 minus a negative 8. And so that means that changes to a plus, and 6 plus 8 is 14. Look at that. My most favorite sound today for notes is the beep beep sound, because the perils of videoing outside. What can you do? What can you do? Okay, we have one more thing to write down, okay? So the conclusion to this part is basically if you're dealing with a polynomial function, like we did from the beginning of the lesson with those ones that we did on Desmos, and then these 2 examples right here, the value of the limit is the value of the function. Okay, so you're going to write that down, and we're going to write it in notation. Folks, we can't be afraid of the notation for this unit. We really got to be up on the notation, and don't let it scare us. Be like, bring it on, notation. I got you. Okay, so the notation is this. If a function f of x is a polynomial function, if a function f of x is a polynomial function on an interval a comma b, so we're starting at a, we're starting at go to b, and c is some number in that interval, okay, then the limit as x approaches c of f of x is simply going to be f of c. Okay, you literally just, here's the instructions, you literally just took that value that x was approaching and you plugged it in. That's all you had to do. So the limit as x approaches c of f of x equals f of c. We have one more guy that sometimes like you're like, I don't even know what this graph looks like. Like, I'm pretty sure that if I really had to do it, I would totally be able to graph the x cubed in my head or on a piece of paper all by myself without consulting Desmos. But what if I can't, right? So then I'm really going to have to look at this. So we're going to do this one on our own. I have my phone right here, okay, running my soundboard. I know, so fun. But I'm going to pull up Desmos and I'm going to graph this guy. I would encourage you guys to do the same thing. So let's go to Desmos, okay? And if I pull up Desmos and I type in for my y equals, it says right here, just sine of x over x. So I'm going to type that in, sine of x divided by x, okay? And this graph says, what is the limit as x approaches 0? Okay, here's the deal. if you plugged in 0, do you know what sign of 0 is? It's actually 0. If you plug in 0 on the bottom, that's 0. Folks, that doesn't even make any sense. Okay? Really, if we plug in 0, we get 0 over 0. And I'm here to tell you that 0 over 0, folks, is mathematical nonsense. No joke. Okay? It doesn't mean anything. So you have to do it a different way. Now, in calculus, we have other ways to deal with it, but we're not in calculus right now. We're in pre-calculus. So we're going to go back and we're just going to graph it on Desmos. So I'm going to pull up my Desmos graph and I'm going to look at it. So I'm looking at the graph, and if X is my target value, X being 0, that graph comes in and it looks like it's about to touch the number 1. Ladies and gentlemen, by looking at this graph, okay, as you approach it from the right and from the left, you're zeroing in on that target spot. It approaches a value of 1. That is the answer to this question. So I guess the moral of today's story is when you do your homework, ladies and gents, there's Katie with her limit does not exist. Okay. Some of these are going to be algebraic in nature, polynomials. You're going to plug some numbers in. Some of them are going to be more graphical in nature, and you're going to go ahead and use Desmos or your graphing calculator, and you're going to graph those. I know, so fun, and I feel like your homework's going to be pretty easy. It does start in the middle, guys. I rearranged how we're going to do this unit a little bit, this section, so we're going to go back and catch some of the earlier ones tomorrow for our next lesson. So that is it for our recording for today. So let me get back over here and get ourselves over here. And so, ladies and gents, that's how we do it. Okay, so you've got a homework assignment ready to rock. You've got a little bit of limit notation. When we have our class time, we're going to even explore this even more, and it's going to be so amazing. I got some songs for us to sing. I'm super excited. Okay, so it's really not songs. It's more like song clips, song 3 seconds. It's going to be pretty amazing. So everybody's going to be having such a great time. So I think that's it. All right, guys, I'm going to send you out with our fanfare music. I hope you had a great day. Enjoy doing your homework. Bye.